A solution of 0.100 molar HCl and a solution of 0.100 molar NaOH are prepared. A 40 milliliter sample of one of the solutions is added to a beaker and then titrated with the other solution. A pH electrode is used to contain the data that are plotted in the titration curve shown above. A. Identify the solution that was initially added to the beaker. Explain your reasoning. So, when it's initially added to the beaker, no volume of titrant is added. So, it will be at the point 0, 1. So when the pH is 1, that will indicate that it is an acidic solution. So the solution that was initially added to the beaker is HCl, as shown from the explanation right here. The solution in the beaker was the 0.100 molar HCl because the initial pH was 1. B. On the titration curve above, circle the point that corresponds to the equivalence point. So the equivalence point for strong acid, strong base titration is always of a pH of 7. So if you look at the graph above, you find that the pH of 7 is on the coordinate point 40 milliliters and 7. So it will be this point right here. C. At the equivalence point, how many moles of titrant have been added? So at the equivalence point, mole acid equals the moles of the base. So to calculate the moles of the base, you multiply 0.11 molar times 40 liters, as indicated from the equivalence point, divided by 1,000 to convert it to liters, which will equal to 0.0400 moles of NaOH. D. The same titration is to be performed again, this time using an indicator. Use the information in the table below to select the best indicator for titration. Explain your choice. So, the best indicator used would be methyl red, as its pH range 4 to 6 is close to the equivalence points, which is a pH of 7. As shown from this explanation. Methyl red will be the best because its color change will occur closest to the equivalence points when the pH changes from about 4 to 10. E. What is the difference between the equivalence point of a titration and the end point of a titration? The equivalence point is when an equal number of moles of the acid reacts completely with an equal number of moles of the base. The endpoint is when the solution starts changing color due to the indicator, which is explained in this right here. The equivalence point in a titration occurs when the number of moles of a titrant added is exactly sufficient to react completely with the number of moles of the titrated species present in the sample being titrated. The end point of a titration is the point in the titration at which the indicator undergoes its color change. F. On the grid provided on the next page, sketch the titration curve that will result if the solutions in the beaker and burette were reversed, i.e. if 40 milliliters of the solution used in the burette in the previous titration were titrated with the solution that was in the beaker. So, for this problem, the volume of titrant added will be HCl. And the initial solution will become the NaOH. Therefore, the initial pH of the solution will be at 13, since the initial solution would be the NaOH. The equivalence points will still be the same, as it is still a strong base, strong acid titration at 40 and 7, like the previous graph. And then you draw the curve below the pH of 2, as it will reach near the pH around the acid.